You can start.
Okay. Well, good morning to all. This is Mahesh Sabnis, and I'm really thankful to all you guys for attending this session organized by Pune Developer Community. We are a non-profit organization majorly into technical activities, doing several seminars and open meets for various professionals and share our knowledge amongst all. Uh, Today, we are going to talk about the .NET security implementation for a web API core precisely. So, again, I'd like to tell you about me. I'm a trainer and consultant with .NET and JavaScript full stack. I'm a Microsoft certified trainer, alumni member, and I'm also ex MVP. Uh, I do trainings. That is my major activity, and I'm also into the consulting. I'm associated with a product-based company in Pune, and I'm their full stack architect for their product. Along with my these activities, I also do blogging on the sites which are mentioned here: devcurry.com, .netcurry.com, right on .NET as well as on JavaScript full stack. And there is one more, that is webnethelper.com. This is also my own blog where I do my knowledge sharing. So all my R&D, everything I put here on this. I expect that most of you are already aware about .NET Core, or probably have also started working on .NET Core. This is the open source cross-platform framework by Microsoft for modern web application development, right? So collectively, with the .NET Core, it is possible for us to work on the web applications which are being developed as per the consumer's need. Ultimately, this technology, that is ASP.NET Core 3.1, this technology makes it possible for us to uh, develop on any platform and deploy on any platform with a similar experience on both. This is the great ever feature which has been provided to us by Microsoft with ASP.NET Core. It might be possible that you use Windows machines for application development with Visual Studio, right? Because we are Microsoft guys, and if we don't have intelligence and appropriate intelligence, we become restless. So it's Visual Studio have given us all the intelligence features with .NET Core SDK, which you can download it from Download Center, and then you can start developing ASP.NET Core applications with the templates provided to us by this. Now, ASP.NET Core, right? What exactly it is? So, since .NET Core is a cross-platform, ASP.NET Core is also cross-platform, but unlike its predecessor, I shouldn't use the term predecessor here, but the thing is that, like, if you're coming from ASP.NET Web Forms or MVC background, or even for that matter, Web API, you should find or understand the core differences between this. So the thing is that our ASP.NET Core Web Forms, MVC, as well as Web API, they are purely based upon IIS. Ultimately, they need the ASP.NET runtime configured on IIS, and then they make a use of uh, the HTTP application, HTTP module, and HTTP handler, these three objects, which actually provides a pipeline for request processing. So they are purely dependent on the host. So unlike this, what ASP.NET Core is, it is a cross-platform, so you can host it on any platform. You can host it on Windows IIS, you can do that. But naturally, for deploying it on IIS, what you need to do is that you have to actually install the ASP.NET Core hosting model. This has to be configured separately. This is what that you have to do it, and it's very important. Okay. The another thing is that what happens is that when you are going to deploy it on the Linux machines, typically, right, you can use Apache, Nginx, and then you can deploy it on it, as well as you can Dockerize it. Okay, you can have the Docker images for that. It can be Dockerized. Now the question arises over here is that then how it is going to provide us the cross-platform hosting support. So that's where something new with this .NET Core comes into the picture and used by ASP.NET Core is a .NET hosting process, which is the one that is going to manage the common pipeline for the entire ASP.NET. And just because of that reason, we say that ASP.NET Core is the unified story for building the web UI, the web user interface, which is now consists of or which has two technologies underlying. The first one is web forms with the Razor views, Razor the lightweight views, as well as MVC, a typical model view controller approach, MVC. We are having these two things. So Razor View web forms and Razor View for MVC. These are the two web UI technologies which are there with us. Not only that, we also have the WebAssembly integration with a .NET Core 3.1 with ASP.NET Core 3.1 called as a Blazor. Right. So for the UI, we do have these technologies. Now, on the other hand, we do have Web API or APIs. You can call it as Web API or just API. What are the Web APIs? So you know that Web APIs are the JSON-based data services with the help of which two homogeneous or heterogeneous applications can talk to each other. So this is the real world definition of these Web APIs. So from your application, if you want to have any B2C or B2B type of integration with other third-party application, then it is always advisable for you to make use of this API. The advantage of this is you are going to have the complete decoupled set of communication across these two applications. That's the biggest advantage that you are going to get because Web API purely subscribe or they are just used through an endpoint subscription. We need not to go for any proxies for that. Though there are some tools available as of today to build a proxy, but still it is not necessary. And then just because of that, they can be easily integral with the third parties, right? It is possible. So we may use ASP.NET Core APIs, and then our customer may have any other application. They might be having the .NET platform app. They might be having Java applications, PHP, even JavaScript full stack with Node.js, or they might be having a simple JavaScript client application built upon using Angular, Vue, or React, whatever it is. So then in these cases, right, what happens is that this REST API need not to be consumed by it, right? So they can simply use an HTTP object model supported by that technology and can work with it. So if it is JavaScript, they use HTTP request object. If it is Microsoft.NET client, we are having HTTP request response object or web client classes and so on and so forth. So naturally, when we are gonna build such type of open endpoint APIs for the data communication, what we have to do is that we have to actually work on the secure approach. We have to think of implementing or going for an application security, appropriately defined application security, and that's a challenging job because architect has to take an appropriate decisions on handling or dealing with these securities. So the first question is that how this is gonna be made possible. So of course, yes, answers lies with this ASP.NET Core platform because it's a unified story. And what it does is that it tells to the developer, it tells to the architect saying that you bother about your domain, plan for your domain, rest leave it on us because we are giving you all the necessary object model. And it is our responsibility to appropriately make a use of this object model while working with the application. So this is what that we have to do. That's the reason we say that ASP.NET Core is a unified story for building the web UI and the APIs, right? That's what the thing is. Uh, Not only that, over here, what happens is that we have the easy integration with the client side libraries and frameworks. So we should be really thankful to Microsoft that because from ASP.NET Core 2.0 onwards, right, 2.x and now it is 3.x, what has happened is that we have been uh, provided with the Angular and React integration. This is there with us, React Redux, those integration. And then there are some community templates available for Vue, right? With the help of which we can directly have one single deployable model for production, which is using server side with ASP.NET Core API and the front end with such type of the uh, front end JavaScript libraries. It is possible. Another thing is that whether it is web API or UI, web UI, they are cloud ready. This is another advantage of it. So we can very easily take this as application services or app services. Precisely, the terminology is app services. We can easily take this to the cloud deployment, and then we can make a use of all these cloud features with this ASP.NET Core. It is possible, and this is applicable for our web API also. Then, typically for the developers as well as for architect, right? We do have another feature is that we do have a built-in dependency injection, right? This is gonna make sure that the dependency objects, or I should say that the plugin type of objects can be easily integrated with our app. We can do that. We can make it possible. Question arises over here is that how it is. So if you have already worked on dependency injection or knowing about it with the help of Unity application block or IOC.NET or Windsor Castle, structure map, simple instance, and so forth with lots of other dependency injection, what you have to do is that you have to install those packages with your application, and then you have to configure the dependency container explicitly, and then what you have to do is you have to use an appropriate strategy of registering your dependency with an appropriate instance management. Means whether the dependency object will be registered as singleton or it's been registered as I should say scope or transient. Scope is purely a stateful thing, and transient is typically a stateless approach, right? So you have to plan for this appropriately. So the thing is that what ASP.NET Core has done is they have come up with built-in support for dependency injection management. So object lifecycle will be taken here based upon the configuration that you provide to an ASP.NET Core. What happens? What's the advantage of this? It is possible, or I should say, it is easily possible and manageable for you to deal with the plugins, right? Some third-party packages. You can directly use them in your application, and with the proper approach of the dependency management, you can make those third-party packages available to your app. You can make that possible. That's advantage. So there is a support of built-in dependency injection to manage the appropriately defined life cycle for your objects. So you can decide which objects will be singleton, which objects will be scope, which objects will be transient. You can decide upon these strategies. Typically, let's say that you are trying to connect to the database, right? The database connection object. Now, this database connection object need not to be made as a singleton, right? You shouldn't do it. So what you want is that whenever the hit takes place, whenever the request is received by your ASP.NET Core application, you want the database instances to be generated. And then when that session is over or when the response is generated and client close the connection, means the response is closed, you want the database connection is to be closed or removed. So you can actually go for the scope-based database instance activation. You can make that thing possible. That's called as a service lifetime in a dependency injection. But if you want to go for an application level logging process, then better you make it as a singleton. So all these things that you can actually manage for your application with the help of this inbuilt support for a dependency injection in ASP.NET Core. So we do have all such type of great features which are commonly used for your web forms, MVC, and web API. And this is the reason why we call it as a unified story for developing the modern applications. Unlike its predecessors, or I should say ASP.NET MVC or web API or web forms on a .NET. So this share the common object model for the request processing in a request pipeline. Request processing in a request pipeline. Now, with your experience, the prior experience of MVC or with ASP.NET, you might have used the terminologies that HTTP handler and HTTP module so many number of times. Right, because if you are a very serious ASP.NET or MVC developer, you have to deal with this HTTP handler and HTTP module, such type of objects for writing any custom type of enhancements for your application. You have to deal with that. But now the fact is that this request pipeline object, that is handler and HTTP module, they are IIS provided, or I must say that they are dependent on IIS. That's the thing. That means if you are using Windows operating system, then you use IIS web server, and then you can deploy your application on IIS web server. This is what that you have to do. So now the question arises over here is that if ASP.NET Core is a cross-platform, then how this request pipeline is being managed? Because why we need this request pipeline? Simple reason. My request must be appropriately handled by my hosting environment, or I should say by my web server. So when the request is received, it should appropriately target to the necessary object model on server. It should locate the controller. It should locate the action. It should locate the page. Prior to that, it should also take care of security, right? Authentication and authorization. It should work with that. So now the question arises over here is that how you are going to manage this or how you are going to work with it. So now the thing is that over here to make it cross-platform or to support the request processing features across all the platform, whether you use IIS, Apache, Nginx, or Docker, right? With respect to all, what ASP.NET Core has done is they have provided us something called as middlewares. Okay, middlewares are there. Middlewares. This is the heart of ASP.NET Core. Heart. Okay, because if you claim that you know ASP.NET Core, but you say that you don't know how to work with middlewares or how to use the middlewares, then simply you don't know what is ASP.NET Core, because the power of ASP.NET Core is been managed by the middleware. This middleware is the one who is responsible for organizing your request pipeline. So request receive and then generating the responses, appropriate responses. That is the responsibility of this middleware. So we have middlewares for security, means authentication, authorization. We have middlewares for exception management. We have middlewares for CORS policies, and so on and so forth. We have middlewares for all. Well, thanks to ASP.NET Core, because we do have some built-in middleware support. They are already organized or provided for our web application. They are already been done. So we already have these things, right? For the middlewares, it's already there. So that is the reason. What happens is that now, when you are gonna work with ASP.NET Core web application, when you are gonna think of going for an ASP.NET Core, okay, then what type of planning that you should do? So the first thing first over here, as per the architecture, you have to choose the technology appropriately for your application development like this. Have a look on the screen over here. So see this. This is the general application development approach. What you can have, right? So uh, if you see that the entire application is structured in three different layers. We have persistent store, the one which is the database. Of course, relational database we primarily focus on, right? We primarily focus on the relational database. But now we should be really thankful to Microsoft for .NET Core, because we have been provided with Entity Framework Core, EF Core. And Entity Framework Core 3.1 means 3.0, 3.1. We have also been provided an integration, or I should say that the ORM based object model for NoSQL database, that is Cosmos DB. Right, Cosmos DB is the multi-model database service on Microsoft Azure, which has SQL API, MongoDB. We do have table services, okay, Graph, right, Cassandra, and all that thing. Okay, we have these type of multi-model database services provided, so we can make a use of this for your application. So it's not always required for you to go for the relational databases. You can also go for the NoSQL, right? That is your persistent layer. Now, for this persistent layer, or to perform the necessary CRUD operations for the persistent layer over here, you make a use of the necessary data access modeling as well as the application logic, right? So you use Entity Framework Core support, right? Typical code first approach, right? Or if you want, you can also go for a database first approach. Means if your database is foolproof and then there is no room for any changes into the database, means you don't want to change any table definitions and so forth, then you can also opt for database first approach. Choice is yours, by the way. But if you are developing an application from scratch, and if you are not sure about the database service that will be used for persistent storage by your customer, then it is advisable that you should make a use of the code first approach. So you can use or go for an appropriate approach, and with the help of DB context and its corresponding migrations, you can interact with the persistent storage. Also, you write your application logic with necessary model classes as well as services. This is your shared library unit, the one which contains your business logic as well as the data access logic. This is called as a shared library unit. The meaning of this is that you can have the separate packages created for data access as well as for application logic as well as services. But the thing is that being a unified story for the application development in ASP.NET Core, all these packages you can give it to MVC application as well as to the web forms with the razor view, and you can also give it to the web API. This means that it is not necessary for you to create separate set of services for MVC or for API as well as for the web forms. because everything is being managed directly by the one single ASP.NET Core application ecosystem, right? So this is the layer which is there on the top, right? The layer on the top over here. So we are having MVC applications with the typical controllers. So these libraries can be given to MVC, or these packages can be given to the MVC, also to the API, also to the web forms. And furthermore, these APIs can be now subscribed by the third-party applications or JavaScript front-end applications or web applications. It is possible. Understood that? So that's how you can do this, or that's how you can plan for it. This is the advantage of going for the ASP.NET Core, because the ecosystem already allows us, or already have provided us, all such features. So this means now what you can do is you can just plan for your business logic, okay, right? Decide what type of data stores or persistable storage technology that you want for your application, and rest use everything from ASP.NET Core from its ecosystem. So we have already been provided with all such type of features in an application. That's how it is. Okay, so this is where you are thinking to go for, or you are supposed to plan for ASP.NET Core apps right here. So this is the, I should say, the great advantage what do we have here of going for an ASP.NET Core. Now the thing is that, what if that we want to develop an ASP.NET Core app with an appropriate architecture? So how should I manage my data access? How should I manage my entities, my logic, and so and so and so forth? How should I go for that? So this ecosystem you can use to work on the application architecture like this. Okay, you can use it for the application development architecture like this over here. So how it is? So the persistable storage. So the earlier diagram which I have shown. So this diagram is basically the detail of the earlier diagram. This diagram is purely projected type of application architecture, I must say. It's a projected type of application architecture. Right. So how it is? So the thing is that now you have persistable storages which will have uh, two different types of database instances preferred. So you are going to have application database server which will contain all the application data, right? Application data server which will contain all the application data, like you're working on an e-commerce, so it will contain all the product information, category information, orders, customers, and so on and so forth. It is always advisable to have this type of database instance separately, right? And for the sake of secure communication or security management, ultimately we say that this is for the sake of the identity management for your application. This identity management, you may be doing it, okay, this identity management you may be doing it through Azure Active Directory, right? Or you might also be having your in-application security database, which will store username, passwords, the multi-factor authentication mechanism, and so forth, which is actually given to us by Microsoft anyways. So if you have worked with ASP.NET MVC earlier, you might have worked on user authentication and role-based authentication. You must have done that already. So that means you should have a separate persistable data store for the identity management, and it has to be completely isolated from the application database. So the reason behind this is that you may keep changing the way the client are going to talk to your application. So if it is just your own e-commerce application, you may have simple user ID password type of login page. But what if that your application will be used by the client as a service? So from your application, you create an API and your client wants to subscribe to that API and tries to work with your application or interact with your application. So how you are going to manage the security? So naturally, identity will definitely be there, but on the top of that, there should be some other additional enhancements that you are supposed to do. In this session, we are anyway going to talk about that after some time. So that's the advantage of having the separate data store for the identity management. So we call it as a identity server. Now for this application data as well as for identity server, you should have separate data access layers. Okay, so you can make a use of ORM, that is Entity Framework Core. You can make a use of that, and then you can work on all the CRUD operations. This is what that you can do it over there. Now, one important thing is that if you are making a use of this identity server for identity management, then what ASP.NET Core has it, they have already provided us the set of classes, set of entities, right, to work with user management, role management, and entire authentication process. We have these things provided to us. We're going to talk about those classes. So unlike in your application, you have to write your entire CRUD type of operation mechanisms with the help of these entities, with the help of entity classes and all. But the thing is that for identity server, we have already been provided with necessary set of objects or classes, right? And it is better for you to use it or to go for it. Excuse me. Right. Now, once we have this on the place, then what you are having is on the other is for the rest of the part of your application. So you are supposed to create the business services repositories, right? Business services repositories means what? So business services repositories are the one which will have the business workflows, your business logic implementation, which will connect to the data access layer, right? And you can also have an authentication workflow implemented over here, with the help of which you can really decide who can talk to which part of the business logic. This is what that you can do. You can plan for it or you can work on it. Okay, so repository services. Now to go for this repository services, what technically you can do is that you can go for implementing the repository design pattern. You can use that. So you can create a repository interface and then you can actually work on this. So now what happens over here is that all the data access layers, whether it is application dial or it is the security data access layer, and also the repository layers, they are supposed to be registered into the dependency injection container. You have to do that, right? This is there. You can put that into the dependency injection container. So what's going to happen is that you will be having objects for security for data access layer as well as for the repository business repository service classes. They are instantiated at application level with a specific strategy. Now typically what happens here is that if it is the security access, right, the security access, it is important for you to uh, implement or go for that uh, security access object registration in appropriate way. So you have to make sure that it should be scope at least, means it should be stateful. Don't make it as stateless. The reason behind this is that when a client makes a call to your application and wants to authenticate itself, you should make sure that once the authentication is done, application should maintain the state of the authentication. That's a practice that you have to follow. So you should make a use of this DI registration policies quite appropriately for your application. You have to do that. It's really very important, right? That's what that you have to do. So security tile, application tile, and repository classes, all you are registering right in the dependency injection container. You are doing that. Okay. Now the next thing is that you are gonna have your API controllers, and your API controllers will be injected. Okay. By the dependencies which are there into the dependency controller. Okay, they will be injected. Right. So what is going to happen is that your API controllers will not have any direct access to the data access layer. Right. It's not going to be there. Okay. Not only that, furthermore, what you are supposed to do is that these controllers, right, must be configured for appropriate set of security. They must be configured for that. So, well, again, here we should be thankful to ASP.NET Core for the same, because in ASP.NET Core, what do we have is we have been provided with three different things. The first one is the authentication and authorization services, we collectively called as the identity services. So in an application builder, you can configure these services, which will make sure that whichever the request that has been received by the application has to be identity verified. It will make sure about it. If the request doesn't contain the necessary identity information, then these identity services will force the user to first register, right? So user has to be registered, and once the user registers, then only that user can make a call to the API or to your application, right? So this is the important things. So part number one for identity through identity services. Number two is that we do have the identity middlewares. What these identity middlewares are going to do is this identity middlewares are going to make sure that the necessary provider has to be used to verify the identity information, right? Necessary provider has to be used. So for that, what it will do is that when the HTTP pipeline is formed, right, means when it is established, for the request processing, it will first of all make sure that the header information as well as body information is to be read, and it has to be mapped to the corresponding identity process. It will be read and it will be mapped to the corresponding identity process. It will take care of that. So this is the part number two. Second, and the third thing over here is that you are now having an actual resource. This actual resource is your controller. Okay, the actual resource is the controller, API controller. This API controller is now gonna configure for the identity, the security, precisely I should say that for authentication. So if the controller or a specific action method from that API controller, if it is demanding the authorization to be done after the authentication, then only the access will be provided to, of that controller to the client. Okay, so there is no anonymous access possible now because your controller says that I am secure. So unless and until the client is validated against the identity, the access of the controller will not be given. That's the thing. So now the question arises over here is that what if we try to do this through API? Okay, what if we are trying to go for the API for this web API, right? So to make that thing possible, we have to plan for our identity appropriately, or I should say carefully. We have to do that. Okay, so now over here, if it is API, a web API, then it is always recommended for us to go for the user management with tokens, right? User management with tokens. It is always recommended for us to follow this as a approach. Now, why? So there are some questions. There are some reasons behind it. Reason number one is that APIs are stateless by nature. Since they are stateless, the web server find it difficult to maintain the identity, or I should say the authenticated session identity. It's difficult for the API to do that. Okay, for the web server to do that precisely. Another thing is that when these APIs are being subscribed by the clients, so we might be having the JavaScript clients, that is Angular client or React client or Vue client or simple jQuery, whoever it is. So these clients are gonna make a call to our API with the help of their AJAX methods or AJAX objects. Like if it is, let's say Angular, in Angular we do have HTTP client. Yes or no? We do have an HTTP client object over there, correct? And then with the help of that HTTP client, the call to the API can be done. And then Angular client makes a call by passing a username and password. And then once they receive the data, right, from the API, they're just going to process that data on the client side. So who cares whether I'm continuously connected to the server or not with an identity? Who cares? There is no reason for the JavaScript application to maintain the identities over there on a client side for user-based authentication. There is no reason for it. So being a stateless, again, we really don't expect that the client is continuously going to make a call for username and password, or with the help of username and password to API to call it. We don't expect it. So how to handle such kind of stuff? So typically, if you are using API controllers, and if you are making a use of the script clients, the JavaScript clients, then it is always recommended that you should go for the token-based authentication. So the thing is that you should appropriately make a use of all the identity APIs and the identity data access mechanism with token-based authentication. So naturally, user ID and password has to be created. You cannot run away from that. But there should be an identity token generated from the server so that all the clients will be able to communicate to your API over that over that token based security, right? That type of architectural changes that you must do, and that is what called as a secure access to the web API. That is the thing. Understood that? So the thing is that over here, when it is ASP.NET Core, being a unified programming model, being the one which has already ready to use classes available for application development, still on the top of that, you have to think of security architecture separately. And that is the exact motive of this session, right? So you have to plan for this appropriately. So how this is going to be handled, right? How this is going to be handled, how this is going to be processed. So the first thing over here is that we have to first of all have a small go through with the middlewares, right? And then we'll see how this entire security thing works, right? We will actually talk about that. Okay, so middlewares. Middlewares are the objects, and these objects are responsible to take care of HTTP request processing in ASP.NET Core application, right? It takes care of the HTTP request processing in the ASP.NET Core applications. They are the middlewares. So they are additional objects which will manage the request processing, additional objects that will manage the request processing in a appropriate pipeline, or I should say channel. This middleware, by comparison, I'll repeat, these middlewares by comparison are the replacement of HTTP module and HTTP handler. Because in the beginning of the session, I already told you that HTTP handler and HTTP module, they are being provided and managed by IIS, and that's only on Windows operating system. So when we are going to go for a cross platform, naturally our ASP.NET Core will be hosted by different web servers, and then there won't be any modules, right? So to provide the request processing experience and request processing management cross platform, ASP.NET Core has this middleware. So in a pipeline, it works like this. So see the request arrows, how they are moving, and see, sorry, see the response arrows over there. So uh, middleware object configuration goes in this order. Exceptions, then we are having the strict transport security HSTS. Then we do have the HTTPS redirections. So HTTP request will be redirected to HTTPS. Then if your application has any static files to be rendered to the client, the static files could be JavaScript files, CSS files, image files, and so on and so forth. So the auto read or reading this HTTPS files and then getting the request for that and including it into the response. So for that, there is a middleware for static file available. Then the routing, then as if it is the API application, then we are having CORS. This is cross origin resource sharing. That's also a middleware. Then we do have authentication, authorization, and then we can have our own custom middlewares, right? If you want, you can keep on writing this custom middlewares, and then finally it will go to the endpoint from where the actual request processing is. The endpoint will now locate which is the controller that is to be executed, or which is the resource, that is our razor view, that is to be executed, or which is the web API class that is to be executed. It will be decided by this endpoint. Now let me tell you, this is the pipeline of .NET Core 3.1. So if you are already aware of .NET Core maybe 2.0 or 2.2, right? So there we were not having anything called as endpoints, but now this has been added. Okay. Now what happens over here in this case? So ASP.NET Core, to deal with this middleware, makes a use of a delegate called as request delegate, REQUST delegate, a request delegate. They make a use of that. This request delegate accepts the input parameter, that is HTTP context. This HTTP context represents the current HTTP request. It represents the current HTTP request. Okay, right? Now, what happens is that when the request is received, it is the request delegate who will responsible for invoking every middleware. So every middleware object here, of course, it's a class which is there with a framework, and this middleware, what it does is that it has a method called as invoke, right? Invoke. And the class which is the middleware class, so exception middleware class, HSTS, these classes are constructor injected with a request delegate. Now what happens here is that the request delegate will execute the invoke method of every middleware object. If that method is executed successfully, it will proceed to the next delegate in a pipeline. I'll repeat. Every middleware object is a constructor delegate, constructor injected with a request delegate. This is a delegate that accepts HTTP context. So now what happens is that the invoke method or invoke async, this method from that middleware object will be executed. If that method is successfully executed, what is going to happen is that the next next middleware in a pipeline will be executed, and then it will proceed with the request processing. At any point of time, when the invoke async method says that something has to be done or a request failed because of some reason, what are the chances? For example, routing fail or CORS fail. What will happen? Immediately the response from that will be generated. So instead of moving further to the next middleware object, it will immediately intercept the request and then it will go back. That's what is going to happen over here with this middleware. This is what we used to do earlier, or we used to implement earlier through the HTTP handler and HTTP module, or precisely with HTTP module, I must say. I used to do this earlier with that. So now we are doing all such things into the middleware. So now, as per as the security is concerned, right? As per as the security is concerned, we do have these two middleware objects. Okay, the first one is authentication, the one which will take care of the authentication, and the second one is here the authorization. So what is going to happen in this case is that here authentication middleware will take care of the user base authentication over here. Sorry, right? So my PPT is moved right over here. So authentication middleware will be responsible to uh, take care of the user base authentication, and the authorization middleware, what it will do is that it will basically take care of the authorization. That's what the thing which is going to happen over there. Okay, right? It's going to happen in that way. Okay, so when we are going to think of going for security implementation, we have to give more importance to this. So the question is how this has been implemented. So now, how these middlewares are used appropriately to go for the security implementation. How we are going to think of that. So I already told you that you as an architect, right, or a developer, and for your .NET Core API, you should take care of this carefully, right? You should take care of this carefully. So you have to appropriately select services, you have to appropriately select your middleware, and then you have to move it accordingly. So now the thing is that the implementation wise. So as far as web API are concerned, we always give more importance to the JSON Web Tokens, JW tokens. We always give importance to that, and then I hope that all of you are having at least some conceptual knowledge or conceptual information about this JW2 tokens. Must be having that. Okay. So now, what is this? So they are the open source, or I should say cross-platform identity mechanism for the REST APIs. They are used for REST APIs which are created using .NET Core, your Node.js, as well as with other technologies. Now, the JSON Web Token is divided into three parts. JSON Web Token has header, payload, and signature. Right? Header, payload, and signature. Now, what is the use of each section? The header furthermore consists of two parts, right? And the first part in this contains actual JW tokens, the actual token which is generated by the algorithm. So you are supposed to select algorithm appropriately again, because based upon this algorithm only the verification is gonna take place. So I should say that this is a type of mechanism for verifying the secrets. That's an algorithm. So the first part is JWT and the second part is algorithm, with the help of which the token will be actually generated and further it will be verified. The second section of the JW token is a payload, and this payload contains claims. This is the most important part of the security management. This is the most important part. Why it is like that? So there is a reason. The reason over here is that the payload that contains claims, they are responsible for authorization. Not only that, they are also used when the token is expired because of the expiry time. So suppose without generating the or without providing the token expire exception to the client, if you really want to generate the or regenerate the token, then what you have to do is you have to basically make a use of the refresh token, and then that refresh token will make a use of this claim and then start the authentication process again internally without informing this to the client. Now this is the part of architecture. You as a developer, you have to think about it or you have to take care of it. Let me tell you, token expiration is a fact, right? Now, in most of the cases, what happens is that if the token is expired, you directly inform to the client that, sorry, your token is no more valid, please log in again. Most of the security critical application, better you should do that. Advise it. But in some application where, let's say that the web API is carrying the data, which needs a huge data entry from the end user. So end user is making the data entry, and then let's say for 10-15 minutes the data entry is happening, the processing on the client side that takes place. 10-15 minutes is a huge time, but it might be possible that your front end is complex enough that it needs so much of the values to be entered by the end user. Now, if that is the case, let's say like visa form, yes or no, that visa form needs a huge information, correct or wrong? So the thing is that, let's say the client is taking enough time to make a data entry, and what if that the token is expired? Now client click on submit button, the request will go to the server and it says that, hey, the token is expired. And now that information will be given to the client, say that log in again. Now, do you expect that the client will log in again and then enter these many values again? It will be difficult. In such case, probably client may dislike your application. He may not use your application. So for that purpose, what you have to do is that you have to generate the refresh token. And then what you have to also do is that you have to then basically make sure that the refresh token will use the claims, and then based upon the claim, auto login should take place or it should be handled, and then the new token has to be generated. But this is the call that you have to take from the architectural point of view. Whatever the products on which work on recently, nowhere we have used this feature. We say no, we will just give the log of information or invalid information to the client, and then we'll manage the expiry time for our token, which is nearly an hour. That's what that we have planned, and we have successfully implemented it. So this is what that you have to take care of it. So payload, the claims, very important. Then the another thing, the last thing is the signature, the one which will take care of the integrity. Okay, integrity, what we call it as a secret. Integrity is actually the secret. And this is exactly the same thing, right? In a kind of a funny example, which I like to give it to you, that like in the older movies, right? In Bollywood movies, right? They used to have those smugglers. They used to go to the mud island to pick the gold, and they used to say that okay, half part of the note is there with the other guy, and this is the half part of the note. If they match together, then only you will be delivered with that gold. Yes or no? सोना तभी मिलेगा जब दोनों नोट जुड़ जाएंगे. Like that. Yes or no? So basically, this is that secret signature. It's the one who is actually going to take care of the integrity, right? Take care of the integrity. So the thing is that this signature can be generated through the cryptographic mechanism from the server side or on the server side, and then that can be added into the token. So this is what that you have to do it, right, with the token based authentication with JSON Web Token. Headers that contain the token and algorithm, payload that contains the claim, and then we do have a signature, the cryptographic secret, okay, which will take care of the integrity. Okay, so now the question arises over here is that how this thing is gonna work. So here, see the application diagram over here, or I should say that the way of going for the token based security, right? So this is the process how it's gonna work. So the thing is that now the client is gonna make the request with the credentials to the application, right? Now, if the credentials are not present, naturally the client has to register it against the application. And then once the credentials, once the client is gonna register, the client is further gonna send those credentials, right? Client is gonna do that. Okay. Uh, so the thing is that now here uh, the the server application is now going to have the verification, the request verification over there. So what server is going to have is that server is going to use the auth request, the logic which has been executed by the middleware, right? And what it is going to do is that this is going to communicate to the data store, the persistable store, right? And the thing is that what's going to happen is that the data store is the one which will actually verify the credentials. Okay. Now, if these credentials are not verified, the no authentication, right, the 401, this request, this response will be sent back to the client. Okay. So credentials are not verified. But if the credentials are verified, what's going to happen is that the token will be generated, right? And then that particular token will be sent back to the client. So client is going to have the token. Client is supposed to store the token, right? Or here at the client's place, So maybe if it is a browser client, it is going to store that information into the browser storage. So this could be local store or this could be session store, right? Now, preference over here is that we should go for the session store if it is the browser application, because session store is highly volatile. So better it has to be stored into that. Right, but then again, based upon what type of client technology that you are going to select, you are supposed to select that. You are supposed to decide that where it will be stored. It's up to you. Now, the token will also be stored into the server's process, right? Or you can also write your own logic of storing the token in a persistable storage on the server side. Okay, again, this is as per your architecture. So I'll give the use case over here is that uh, you want to take care of the refresh token integrity, right? If the token is expired, so if the access token, your JW token is expired, and now you want to generate the new token by auto authentication mechanism, then what you can also do is you can store the access token and refresh token both at the database server. Then whenever the token is means the client is going to send this token to the server, you just verify the token against the persistable store and then perform the necessary auto login and regeneration of the token. That process you can execute it on the server side. So this is the call that you can take it further, right? So now the token is available on server side and then it will be given to the client also. Now, what's going to happen is that client is going to make the request by putting the token into the header, right? So HTTP request will be formed by the client application. It will create the authorization header, and then in an authorization header, this bearer token will be put, and then that will be sent to the server, right? Our ASP.NET Core application precisely. Now, what's going to happen? The next thing here is that the server application will now start verifying the token. So again, it is gonna use the same secret, same algorithm, right, to check for the integrity of the token, right, by going for the token verification. If the token is verified, then absolutely no problem. Or if, so the response will be given back to the client. But if the token failed, then what's going to happen is that the 401 response that will be again sent back to the client. So this is how it's going to happen. So the response will be sent to the client based upon the token, right? Based upon the token validation status. If it is valid, then that's fine, right? Give the access from for the resource. So the web API response with whatever the data that can be actually sent back to the client application, that can be made possible over here. So this is how it is. So the thing is that we do have this entire stuff, means whatever the object model, the set of objects, right, the algorithms and all which are required for this token authentication, everything is already been offered to us by Microsoft in ASP.NET Core over there. Now the thing is that like it's a middleware. If you see that the middleware which we have talked about that in the earlier slide, okay, the middleware's authentication and authorization blocks, these middlewares are going to take care of all this, right? Now the thing is that the questions are like why that authentication and authorizations are at the lower level into the pipeline, why exception is there on the top and why it is there at the bottom. So there are some reasons behind it. Middlewares are the one, they are supposed to get executed, correct, when the request is received. Now the middleware like exception, what it does is that it is actually gonna inform to the request that hey request, don't worry, I'm gonna have the exception management logic which is already initialized. So if somewhere during the request processing, if the exception occur, immediately the exception middleware will come into the picture and it will throw out the response back. This is what is going to happen. So since it is like a global exception module for your application in a middleware pipeline, that exception middleware is kept on the top. That's what the reason is. Okay, that's what the reason by keeping it at the top level. So some of you might also be thinking that authentication and authorization should be there on the top. Well, as far as the execution process is concerned, for the security, you feel like the authentication and authorization is getting executed on the top. You may, that it gives you that type of experiences. But the thing is that before authentication and authorization, there are additional objects into the request pipeline that must be initialized and that must be kept into an execution state. For example, CORS, or for example, static files. For example, HTTPS redirection. So this is what we need prior to go to the authentication and authorization process, and that is the reason why they are they are kept on the top. Okay. Now another thing is that the tokens are so sensitive by their algorithm, so it is not necessary for you to really bother about any type of attack. So if you are handling this appropriately on the server side, then you need not to really worry about it. Now the thing is that the payload and the payload and the token, right? So in one of the training program also I was asked such type of questions, is that like payload and the algorithm, these are given to the client, right? Then question is that how it is been secure. Okay, no need to worry about it. Why it is happening is that the client must have something to send so that the server can validate the request. So the token is the type of identity guarantee which I'm giving to the client, saying that your username and passwords, you send it to me, right? Username and password, your identity is appropriate, your credentials are validated, and this is what the identity that we are giving it to you. But against that identity, there is an integrity value which is kept by the server on the server side. So if somebody still try to play with that particular token, try to modify or do something and then send the request back to the server, okay, with that modified or morph token, I say it is the server who is actually having the necessary algorithm integrity check, what we call it as the verification. And this is the reason why we say that they are the secure one. So if there is somebody who alter the token, morph the token, right, still the server is having the necessary set of secret validation mechanism, with the help of which this is gonna be secure. So you still need not to worry about it, and that's the reason we say that when we are gonna go for the web API with a cross-platform set of REST API identity, we should go for the JW tokens. So now how it is. So let me take you to the application over here, right? This is the application. Now let me tell you a couple of important things over here. So if you just go to, let's say, https://webnethelper.com, right? If you go on this website over there, have a look that I have already written the entire explanation article on this website, and whatever the code that I'm gonna show, that entire code is already present. Okay, that code is already present online, so you can make a use of that. Correct. Okay, so that is it. So understanding token-based authentication in ASP.NET Core 3.5, right? Using JWT that I already have. Clear here? Okay, so there also I have explained all the things. Excuse me. So now let's go back to the application over here. So as per the diagram, right, architecture thing, I already told you that you should have the separate database for storing an application data, and you should also have the separate database for storing the application credentials, right? Username, password, then role information, if any, right? You should have all the things over there. So the question arises over here is that, like, then how you are going to manage it through your application? So this is my ASP.NET Core 3.1 application over here. I'll actually like to take you to the properties over here. This is my .NET Core 3.1, and over here now I'll take you to the app settings.json. So in this app settings.json, what I have is that I have the uh, application. I do have a connection string. So there are two connection strings. They are kept here. One is the uh, app context uh, data app context connection. This is a connection string which where the application data is kept. Then there is another connection string available, that is security DB context connection string, and then this security DB context connection string is now gonna contain all my security information, that is the username and password. Not only that, over here I need the secret for integrity management for my token, as well as I need a expiry token expiry. So this is what is there with me. So JWT core settings. So the secret key here, this is the secret key. Now this secret key is actually being generated with the help of the cryptographic algorithm. So if you see on my project, in this solution, I already have the console app, the program.cs, and over here I'm using system.security.cryptography, and there I'm having this logic that is written. So what I'm doing is that I'm using this RNG crypto service provider, this class, and then I'm gonna generate the 64-bit encrypted key. So if I run this now over here, okay, so this is gonna give me the encrypted key, right? It's gonna give me that, right? Here it is. This is it. So this is what is it actually been copied and has been used over here into the app settings.json, right? So that's what my key is. Okay, and then the expiry in minutes in 20. All right, so this is the token will have the 20 minutes lifetime there. Okay, now going back over here, I'm gonna expand my dependencies, right? And with the packages, since I'm gonna use the database for storing my username and password over there, I have to also import some packages. So Microsoft.ASP.NET Core.Identity, this is the package that will be used for for accessing the identity classes like identity user, identity role, then all those necessary classes. Then Microsoft.ASP.NET Core.Identity.Framework Entity Framework Core. Microsoft.ASP.NET Core.Identity.Entity Framework Core. This is the one which will actually provide us the ASP.NET, Entity Framework DB context object, Identity DB context object, with the help of which will connect to the database and will store the data into the ASP.NET users as well as ASP.NET roles table. We'll do that. Okay, then for our application access, we need this entity framework core and design and all that stuff. Then Microsoft.ASP.NET Core.Identity.UI. This is the one which will provide us a service which will be registered into the ASP.NET Core for identity management. Okay, so this is the one which will store the identity service into the DI container, right? It's gonna do that. Then on the top of that, we also need two separate packages. The first one is system.identitymodel.tokens.jwt. We need this. This is the one which will provide us the necessary classes for generating the JW token, right, in our application. And then Microsoft.ASP.NET Core.Authentication.jwt bearer. This is the one which will actually provide us the service for JW authentication, right? JW authentication, as well as the token validations with necessary validation parameters. We are gonna get it from this Microsoft.ASP.NET Core.Authentication.jwt bearer. Okay, that's what that we are gonna get. Okay, so now let's go here. So the first thing first, what I do have is that I do have the authentication service file where I have the class called as core auth service. This is the class available, and this class is the one which is going to contain two important methods. The first is that it contains a method to register the new user, and the second thing is that it contains another method to authenticate the user and then generate the token. Now to do that, this class must be constructor injected with three different things. It should be injected with iConfiguration interface, the interface which will be responsible to provide the configuration values from appsettings.json, right? So we have connection string, we are having JWT settings and all in our appsettings.json, which I have shown you before some time. They will be read from this iConfiguration. Then two more classes, sign-in manager and user manager. Both are generic classes. The user manager is of the type identity user, which will actually create the ASP.NET user in a ASP.NET user table. Sign-in manager again is of the type identity user. This will actually provide the login process. It will accept username and password, and then it will provide the login. Now, identity user is the class which contains the user management properties like username, password, user ID, email, and so on and so forth. All are here into this identity user. So these three are injected, constructor injected into my class. Now, I do have a method called as register user AC. This is an asynchronous method and that accepts the register user class. So where it is? So in my models folder, okay, if I go to the models folder, in the models folder, I have user model.cs and this contains these two classes. The register user, which has three properties, email, password, and confirm password with the necessary validation, means the annotation validation. And then there exists another class called as login user, which also has a username and password. So the register user will be used to register the user and the login user will be used for the login process. That's what is going to happen there. So now in my core auth class, right, core auth service class, the register user method, it accepts the register user, and what it is going to do is that it is going to store the information of the register user into the identity user class with the username, that is the email which will be sent by my client application, and then with the help of create async method of my user manager class, it will create the new user. It will create a user and it will register that particular user, right? So the first parameter to the create async method is the user information and the second parameter is the password. So what this create user method does is that this create user method is actually hash the password. This is how it's going to happen over there. Okay. Then the next method over here is the authenticate user async. Again, this is an asynchronous method which accepts the user login user as a parameter, which is taking username and password. Now, what this method is going to do? This method makes a use of the password sign-in async method of the sign-in manager, which accepts the username, password, two parameter. The third one is for persist, and the fourth one is the lockout on failure. Okay, so what is going to happen is that the method password signing async, this will check whether the credential matches against the data store or not. If they match, they will say that the user is logged in successfully. And now here we do have the major part of our implementation. So in this, we are actually going to generate the token. So for that, we need a secret key as well as the expiry time. So that we are reading it from the app settings.json with the help of the configuration or iConfiguration interface. Then the next thing what we are doing is that we are creating an instance of an identity user, and what that identity user contains. Now this contains the username which is being sent through the login method. Now we are having the security token descriptor. The security token descriptor, this is the class over here. This is coming from the JW token, right? Then the package which we have already installed into the project. And now what it is going to do is that it is going to set the properties for the token description. Issuer, who is the token issuer? Right now this is null. Again, the audience, which I'm keeping null for this demo. Then the subject, where the payload is gonna be configured, ultimately the claim, right? The claim. So over here, this is the username that I'm using. If you want to go for role based, you can have the role. This is up to you. Then I'm setting the expiry, right, and the other token issue information. Now the another important thing is that I'm supposed to configure the security credentials with the secret key, and then its corresponding encryption algorithm. So here, this is the one, the signing credential. This is the one which is gonna sign the token with the secret and the corresponding algorithm. So this algorithm is the one which I'm gonna use for the overall token value encryptions. So I'm using HMAC SHA-256 signature. So this is my token security description, right? With the help of security token descriptor class. Now, once it is done, now the next thing is that I'm using this description to create the JSON security token, right? With the help of the class called as JWT security token handler. This JWT security token handler is the one which will actually create the token with a 3 section, that is header, payload, and the signature. And then that token will be written, and it will be written from this method. Okay, so this is what is going to happen. So if the login is successful, then only the token will be generated. If the login is successful, then only the token will be generated. That's what is going to happen. Now, the next thing is that this is my class, my authentication service class. This authentication service class is now used by this auth controller API. So this is my auth control API. This is my web API, the .NET Core. And now this controller is constructor injected with the core auth service. Constructor injected with the core auth service. And hence it is going to have access to the register method as well as login method. So now this controller has two HTTP post method. The first one is the register async. This method will accept the email password and confirm password through this register user object, and then will make a call to the register user async method from authentication service, and then it is gonna create the user. So if user is already present, it will return conflict. Otherwise, it is gonna return the response in a serialized form as a message over here that the user created successfully. This is my register method. Okay. Now, the next one over here is that I'm going to go to the next method over here. So I do have next, that is the login method. This login method is gonna accept the login user as an input, and then it is gonna make a call to this authenticate user async method. Okay, and this is gonna check whether the username and password is been successfully present on the server. If it is there, then it will generate the token and then it will response it back. So now over here I'm making a use of the JWT bearer, those packages which are provided to us by Microsoft with ASP.NET Core. On the top of that, if you can use, you can also make a use of Auth0 API. Unfortunately, these are not used in the current session. They are not using that Auth0. Okay. But offline, if you want to communicate to me, right, I'll share my email address, right? You can basically connect to me and then I can share that particular demonstration all to you. But here we are not considering that scenario. Here we are generating of our own with the help of whatever is the feature, whatever the features which are provided to us by ASP.NET Core. Got my point? Okay, so no Auth0 scenario we are considering here, right? Now, these are the two API methods, but now how this entire orchestration work, right, for our ASP.NET Core application. So we have created auth service. We also have the controller, but the thing is that we are supposed to write the token verification service configuration. So for that, let us go to the startup.cs. This is the startup.cs over here. And now we are injecting the security DB context. The security DB context, this is what the class is there into the model. This is derived from identity concept. So identity DB context. This identity DB context is the one which will connect to the database where our ASP.NET users, that user information is stored, right? For that, we already had that connection string over here into the app settings.json. So this is what the connection string, right? We are having ms equal local db and then we are having the app security db, right? That's what it is. So what I'm going to do is that I'll just go to the SQL server over here. Okay. And what I'm going to do is that here. So let this be started. So we are having the security DB context that is registered. And then we are also registering the identity user against that security DB context. So what is going to happen is that our identity is registered into the service. So here we are informing to our ASP.NET Core application is that the request which are coming from the client, they will pass the identity information, and for those identity information, connect to the database server using the connection string, and then connect to the security DB context and then verify the user management. This is what we are doing with the help of this add default identity. Then we also have the application connection string over here. It is there in our app settings.json, the app DB, that's the database. So here now, let's go to the database server over here, connect. I'm connecting to the local DB into the database. Okay, so I'm gonna have the security DB context, right? What is the name of that? App security DB. Let's say that this is my app security DB database. I'm gonna have ASP.NET users, right? And this is it. I already have one user over there. I'm just gonna delete that. Okay. And then I'm gonna have the app DB. This is gonna contain the products table, right? Then I do have some products. So this is my security database, and then this is my application database. I have two database instances over there which are separate. Okay. So now they are registered into my startup.cs here. Then I'm registering my core auth service into the dependency injection. I'm doing that. And now what I need to do is that I need to go for the token based authentication validation. So for that, I again need the schema to be accessed from the configuration. So here it is. I'm getting that secret key from the configuration over here, and I'm storing it into my bytes array. Then this is my add authentication service configuration, right? Where I'm saying that the authentication is the JSON authentication, right? So we are giving the authentication scheme as JSON bearer defaults that we are configuring. And then for that, I'm adding another service called as add JW2 bearer, where I'm gonna take care of the the token validation parameter for validating the token. So the class is token validation parameter over here. So it will say that validate issuer key true. So the issuer key, right, with the help of which I'm signing the token, that secret key, right, that has to be used to verify the token. This is what I'm putting here. I'll say that issuer signing key is equals to new symmetric key and passing the secret key. I'm passing this key information with the help of which my token will be validated. Right. So these are the two important properties that are supposed to set for token validation parameter. Moving further on this, right, if the token is expired, then what is to be done? So I'm registering the JWT bearer events object. I'm registering to that. And here if I say that if the token authentication failed, right, I'm gonna send a response back that the authentication token is expired. So if the token is expired, then I'm saying that authentication token is expired, and then I'll log off the client. Okay, now this is where what we can also do is that we can also go for an additional logic for going for refresh tokens and then regenerating the JW token again. We can do that. So that is the additional security thing as per the architecture that you need to do. This is what I already told you. So if something goes wrong and the token validation failed, right, because of the token expire, what we are going to do is that we are going to send the response that is the authentication failed to the client. This is what that we are going to do. So this is here that we set, right, for the token validation. And then in my configure method where all the middlewares are configured, over here I'm specifying here authentication and authorization. So if you see that this is what the exact order that I'm setting, yes or no, exception on the top again, right, then HSTS, then HTTPS redirections, static files, UCRS, routing, then use authentication, use authorization, and finally the endpoint. Correct. So this is it. Now, once this token based authentication is the token is verified, my client will make a call to my another controller, that is the products controller, and this is applied with authorize, right? Okay. Okay, so this is it. Now, of course, yes, over here you can also make a use of the OpenID, right? The feature with Azure Active Directory, right? My Azure AD features, you can integrate that also with your web API. Okay, and that will also have a client secret client ID generated. Okay, that's another approach. So that's another way of securing your API. Correct? Okay, so now I'm going to put a breakpoint on this. It's already there. I'm going to put a breakpoint on my register method. Okay, and now my URL will be api/auth/ the name of the action, that is register, and then login. Okay, so that's what the thing is. So register takes email, password, register user takes email, password, and confirm password. And the login user is gonna take username and password. That's it. Now just go to the postman, right? And then I'm gonna start my application also over here. Okay, so let the application be started. So I'm using the self-hosting thing on the port 5000, right? Okay, going here. Okay, right. And now over here, I just make a post request, http://localhost:5000/API/ I'll have auth. That's the name of the controller. Okay, here, and then the method register. I'll go for the headers here. I'll say content type application/JSON. In the body, I'm gonna pass here email. I'll have sample1@abc.com. Right. I'll have password ads and have password. Then I'm also gonna say here confirm password. Right. Okay. Send the right over here. Say that localhost 5000. Right. I put 500. Sorry, my bad. So here it's gonna go here. Right. The data will be received. I just say right. The user has to be created. Okay. F5. So I'm gonna get the message here that the sample1@abc, this is created successfully. And now if I take you to the database over here, I just say refresh this. Okay, that is created. Now what I'm gonna do is that I'm just gonna copy this, right? Post, and here the other method is login. Right, that's the other method here, the login. So I'll pass this login and headers over here. I'll have content type is application/JSON. Body, I'll pass here username as sample1@abc.com, and then I'm gonna have password as password. Correct. And so here it is going right. It's successful. Okay, so this is gonna generate the token. So that token is here, right? Now I'll make a GET call to my products API. I'll say that http://localhost, right, :5000/API/products. And if I just make a call over here, send, okay, what's going to happen is that it's getting unauthorized, because what happens is that the products API is expecting the security value. It is using the authorized over there. So what I'm going to do is that I'm just going to go to the headers, I'll pass authorization header with a error value, and I'm going to pass the entire token. So this is my token, copy and paste, send. So now the request has been accepted by my products controller. FIU here, and this is how it is giving me the entire data. Correct. Likewise, now if I just go here and I just tamper this, I pass here like this, send. I'm gonna get an error because I have tampered that token. Got it. So this is how you can actually go for the secure APIs, right? Now you can also deploy this on a cloud. You can use the OpenID Connect API, right, on Microsoft Azure with an Active Directory. You can also secure it, okay, or you can use the OAuth 0 APIs for building the secure API into the ASP.NET Core. So this is how it is that you should plan. Now, why I have chosen for JW tokens? Because most of the time when you are building the web API for the open clients, but you want to manage the security from those clients, it is always advisable and better for you to go for the JW token authentication. That's what the thing is. But this is not the only feature. Okay, you can go for the OpenID Connect as well as you can use the Auth 0 set of the APIs. Right. So this is what the thing is. I have already shared my the blog where the whole solution, right? This whole solution is present over here, right? If you want, I can again show that to you. You can go to the webnethelper.com, https://webnethelper.com, and then you can uh, go through this. So here in this article, I have explained the entire thing, that how you can actually build the application from scratch. So there I have explained everything. Correct? Everything I have explained over there. So it's the same demonstration. Correct? Okay. Right. So this is it. Well, so that's the thing. Clear? So if you have any doubts, any question, you can go for that. Well, thank you very much. Okay. Okay. Right. So thanks a lot. Here during the session, I have already answered these questions on OpenID as well as on Auth 0. Right. I already answers on this. Right. So you can further connect me on my email address, which I have already shared with you. That is subnis_m@hotmail.com, and we can have further connect. Well, thank you very much. Thanks a lot.